We are starting this class today. I don't know the course code you have used to register. It used to be FSC 115, but with the new CC mass, it's been changed to PHY/CM 101.
Yes, sir.
But if it's FSC
Yes, sir.
115, you have in your registration, it's still the same course that we are taking. So this is the first class for this course. So we are going to look at measurement. And under measurement, we look at the space and time, unit, and dimension. So as for introduction, we have here definition of physics. So physics is a branch of science that deals with nature and the relationship between matter and energy. The study of how matter and energy are related. That is physics. So I've created a YouTube link for this class so that you can always go back to the YouTube to watch, listen to the class over and over again, so that wherever you miss out, you can always, you have a backup.
All right, sir. Thank you,
To
sir.
always go over again. Don't forget to click the subscribe button so that subsequent classes, I will not need to be sending link. Once I come online, you will be prompted to join the class. So physics is a natural science that is based on experiments, measurement, and mathematical analysis with the purpose of finding physical laws that governs everything in the universe. So someone may be asking, why do we do practicals in physics? Why is that? Why is it that there is always calculation in physics? So that is the nature of the course. And the purpose is to find a physical law that governs the universe. So what is physical quantities? Physical quantities are physical properties in physics that can be measured. Anything that can be measured is regarded as physical quantity. Whatever you can measure, whatever physical properties that you can measure is a physical quantity. Now, when we do measurement, we represent the outcome in two parts. We have the numeric part, and then we have the alphabetical part. The numeric part tells us of the size, the magnitude, the amount that was measured, while the alphabetical part tells us about the unit. That is the specific physical quantity that was measured. For instance, if we measure mass, it is appropriate to write the value measured and the unit. So e.g. there, we have 20 kg. Seeing 20 kg would immediately tell us that the quantity that was measured is mass. But if I write just only 20 is just a number, and it will just tell you the size, the magnitude, the amount, but it will not tell you which quantity was measured. So 20 is just a number. That is why in physics, units are very important because it's the unit that will tell us which physical quantity was measured. So unit is very, very important. Now, measurement. Measurement is a process of detecting an unknown physical quantity by using standard quantity. So there are standard quantities that is accepted worldwide. So whenever we make a measurement, we make reference to the standard quantity. That is why, for instance, in your table plastic bottle water, you will see the size. If it is 50 cl, 75 cl, 1 liter, you know that once you carry the bottle, you know that, okay, this is 50 cl, this is 1 liter, this is 75 cl, because it's a standard that has been measured or acceptable universally. So every measurement must be made reference to a standard quantity. Now, we should also know that no measurement is exact. There is always some uncertainty due to one, limited instrument accuracy, which is classified as systematic error, or difficulty reading results by the experimenter, which is classified as random or human error. So whenever we make a measurement, either of these two errors may occur. That is error coming from the person carrying out the experiment, or error that is inherent in the apparatus being used for the measurement. So we have these two classes of error: systematic error and human or random error. And that tells us that experiments are never 100% accurate. There will always be an uncertainty, little shift in the final results. So how do we minimize error due to random or error due to systematic? Random error is error that is caused by the person carrying out the experiment. So one way to minimize such error is to take repeated readings. When you take repeated readings and find the average, you are able to minimize the error. And also sometimes in physics practical, they will ask, give precaution. And one of the regular precaution that student used to give is avoiding parallax error, which means that you are reading taking must be at high length. Your eyes must be straight when you are taking reading to avoid that parallax error in reading. Then for systematic error, that's error that comes with the apparatus. Maybe the apparatus is faulty or is not standardized, is not calibrated. So in that case, or the apparatus is spoiled, in that case, what we should do is if it needs to be recalibrated, the apparatus should be recalibrated to minimize systematic error. If it is faulty and it can be repaired, the apparatus should be repaired to minimize systematic error. And if cannot be repaired, then you replace the apparatus. to avoid systematic error. So these are some of the ways to minimize error in measurement. Physical quantities are classified into three. We have the fundamental quantity, we have the derived quantity, and then we also have supplementary quantity. We have fundamental quantity, derived quantity, and supplementary quantity. These are the three categories of physical quantity. So let's look at them. What is fundamental quantity? So fundamental quantities are quantities which are distinct in nature. They cannot be defined by other quantities, but upon which other physical quantities are derived. I take it again, they are quantities which are distinct in nature. They cannot be defined by other quantities, but upon which other physical quantities are derived. There are 7 in number. There are 7 base quantity or fundamental quantities. The first one is mass. We have length, we have time, we have current, we have temperature, we have amount of substance, and luminous intensity. Okay, so yeah, luminous intensity. So these are the fundamental quantities or base quantities. Now, the symbols are there. For mass, we have M, length L, time T, current I, temperature capital T, time is small letter t, and temperature capital letter T, amount of substance N, and luminous intensity I subscript V. And the unit of mass is kg. The unit of length is meter, M. The unit of time is second, S. The unit of current, ampere, A. Unit of temperature is Kelvin, K. For temperature, we have 3 scales of measurement. We have the Kelvin scale, we have the Celsius or degrees Celsius or centigrade, and we have the Fahrenheit scale. Then amount of substance, mole, MOL, and luminous intensity, candela, CD. Now, the second physical category of physical quantity is derived quantities. They are quantities whose definitions are based on other physical quantities. They are just like the name sound, derived quantities. They are derived from the fundamental quantities by multiplying 2 or more fundamental quantities, or by dividing 2 or more fundamental quantities, or multiplying and dividing 2 or more fundamental quantities. So example of derived quantities are displacement, speed, velocity, acceleration, force, energy, density, moment, power, work, momentum, pressure. Pressure is force over area. So force over area, we are dividing two quantities to give pressure. Momentum, mass times velocity, we are multiplying two quantities to give momentum. Work, force times displacement. We are multiplying two quantities to get work done, which is a derived quantity. So the third category of physical quantity is supplementary quantities. They are geometrical quantities of circle and sphere, such as plane angle and solid angle. If you notice, the two categories of quantities, physical quantities we mentioned before, that is fundamental quantities and derived quantity. We didn't mention anything angle. So this third category of physical quantities where that is taken care of. So we have plane angle and solid angles as supplementary quantities. Supplementary quantities. So now each of these quantities, you remember that we also mentioned their units. Unit is very important, like I said before. So for fundamental quantities, we have fundamental units. For derived quantities, we have derived units. And for supplementary quantities, we have supplementary units. So what is a unit? A unit is a physical quantity that can be counted or measured using standard size defined by custom or law. A unit specifies the physical quantity that was measured. So that's what a unit is. So units are standards for expressing and comparing the measurement of physical quantities. So we have examples there. We have the SI units, and we have the British system of unit. And the SI unit, which is International System of Unit, and then the British system of unit. Now, we have different standard system that you need to know. Different standard system of units. The first one is CGS system. The CGS system is the centimeter gram second system. Centimeter gram second system. And we also have the FPS system, which is foot pound second system. Foot pound second system. That is in the British system of units. We have that. Then we have the MKS, which is meter, kilogram, second system. Meter, kilogram, second system. Meter, kilogram, second system. MKS. So these are basically the three metric systems that we have: CGS, MKS, and FPS. CGS, MKS, and FPS. So unit conversion. Now we can convert from one unit system to another. For instance, if it could be given values in millimeter and then asked to convert to meter, or in cm to meter. Or for instance, you are given a problem to solve and you notice that the units are not uniform, then you will need to convert all the units to standard units. So while you are doing that, you have to take cognizance of all the metric system. We have basically the SI unit, which is MKS, then we have the CGS. So if all your units are in CGS, you can continue with your calculation. If they are in MKS, you can continue with your calculation. But if it is mixed, you have some of the parameters in MKS, some of them in CGS, then you will need to convert all the CGS to MKS. But while you do that, also ensure that there is no condition attached to the question requesting that you leave your answer in a particular system of unit. For instance, if you are given problems in MKS and CGS combined, and you are asked to leave your answer in CGS form, it means that you have to convert all MKS to CGS and solve. But if the question is silent about the final metric system, and you have a combined metric system, the best to do is to convert all your units to standard system of unit, that is SI unit, which is the MKS. So here is a simple example to play around with. We have movement from kilometer to meter to centimeter to millimeter. So if I'm to move from kilometer to meter, it means I will multiply. Look at the upper part. Look at the diagram here. The one at the upper part. So if I'm to move from kilometer to convert from kilometer to meter, it means that I will multiply with 1,000. If I'm to move from meter to centimeter, I will multiply by 100. If I'm to move from centimeter to millimeter, I'm to multiply by 10. Now, the reverse is the case. If I'm to move from millimeter to centimeter, I'll divide by 10. If I'm to move from centimeter to meter, I'll divide by 100. If I'm to move from meter to kilometer, I'll divide by 1,000. So if I'm to move from millimeter to meter, what should I do? Millimeter to meter. It means that I would divide, I'm going 2 steps, so that would be 10 and 100. So I'll divide by 1,000. If I'm to go from millimeter to kilometer, that is, I'm going 3 steps at a time, that is 1,000 and another 1,000, that is 10 raised to 6. I'll divide by 6 zeros, 6 zeros. So example 1. Example 1. 5 kilometer to meter will be what? Five kilometer to meter will be times 1,000, that is 5,000.
Yes, sir.
So example 2, 600 cm to meter. 600 cm to meter. If we are to convert 600 centimeter to meter, remember, so that you take the downward approach. So that would be divided by 100. So that would be 6. Then example 3, 8 cm, 8 centimeter to millimeter. So we are going up this time, cm to millimeter. So that would be times 10. So that would be 80. Example 4, kilometer, you are converting 400 meter to kilometer. So that is down. So you divide by 1,000. We divide by 1,000, that will give us what?
4.
4. 4 kilometer is equal to 4,000 meter. And then you should be able to solve the rest examples that are there.
Sorry, sir. Sir, please, I have a question, sir. Sir, please, I have a question, sir.
So meter to meter square, centimeter to meter square, a millimeter to give me a minute. So if you are given something like this, meter to meter square, of course, that one is you multiply m times m gives you m square. That one is easy. Centimeter to meter square, you have to first centimeter to meter square. You have to first convert centimeter to meter. Remember, if you are converting centimeter to meter, you divide by 100. So when you have converted centimeter to meter by dividing by 100, then you multiply by meter to get your meter square. So the same thing applies to all of them. Millimeter to meter square, you have to first convert the millimeter to millimeter square. You have to first convert the millimeter to meter, and then you square it, or you will first convert millimeter to millimeter square. So when it's in millimeter square, you can now migrate to meter square. The two must be in the same unit before you can convert from meter to meter square. Time zone conversion. Year to months to weeks to days, hours, minutes, and seconds. Then we can also convert months to weeks, days, hours, minutes, and seconds. Weeks to days, hours, minutes, and seconds. Days to hours, minutes, and seconds. Hours to minutes and seconds. Then minutes and seconds. Minutes to seconds. So if we are to convert year to second, you have to break it down. How many days how many months do we have in a year? We have 12 months. Now, how many weeks do we have in a year? We have 52 weeks. How many days do we have in a year? 365 days, except it's a leap year. So now, how many days, how many hours do we have in a day? 24 hours. How many minutes do we have in 1 hour? 60 minutes. And how many seconds do we have in a minute? We have 60 seconds. So you multiply them all through. So 1 hour is equal to 60 minutes. 1 minute is equal to 60 seconds. 1 hour is 60 minutes. That is 60 and 60 will give you 3,600 seconds. 1 day is equal to 24 hours. 1 week is equal to 7 days. 1 year is equal to 365 days. 1 year is 12 months. 1 year is 52 weeks. So here we have an example. How many minutes are there in a year? how many minutes do we have in a year? So the first thing to do is to know how many days we have in a year. That is 365. How many hours do we have in a day? 24. So 365 times 24 will give us our conversion in up to hours. So we since we are going to minutes, we have to convert how many minutes do we have in 1 hour? 60. So multiply by 60 will give us our year converted into minutes. So that is 365 times 24 times 60. 365 days in a year, 24 hours in a day, 60 minutes in 1 hour. If we multiply them together, we have 525600 minutes. Now, how many hours do we have in a year? So if it is hours, we'll have 24 times 365. That should be 8760. 8760. So do we have any questions so far?
Yes, sir. I have a question, sir.
So let's move
Yes,
on
I have a
to.
question, sir. Sir, can you hear
What's
me,
your
sir?
question?
Okay, sir. I uh, in the previous slide in the
You are not
conversion
audible.
from
Speak out.
okay in the conversion from millimeter to centimeter and to
Conversion.
meter. Yes.
Can you type it? I can't hear your voice.
Okay. In the conversion from meter to centimeter and to meter, you said as if we are to convert back from millimeter to meter, it will be 1000.
Send it as chat. I can't hear what you are saying.
Okay, sir. Okay, sir.
All right, so let's move on. Dimensions and dimension analysis. The dimensions of a physical quantity. Okay, if we are to convert millimeter to centimeter. Now, if you are moving from lower units to higher units, you divide. But if you are moving from higher unit to lower unit, you multiply. So from millimeter to centimeter, you divide by 10. If you are going from centimeter to millimeter, you multiply by 10. From millimeter to centimeter, you divide by 10. From centimeter to millimeter, you multiply by 10. The same way applies to the other unit. Kilometer, okay, so from millimeter to meter, you, millimeter to meter, you multiply by 1000. is from centimeter to, let me take you back. Centimeter to meter, that is 100.
Okay.
Look at it. Here, if I'm going from centimeter to meter, I divide by 100. So if I'm going from millimeter to meter, this is 100, this is 10. So if I multiply 100 and 10, it will give me 1,000, which means I'm going to divide by 1,000. If I'm going from millimeter to meter, is 1,000. Okay, you've gotten it. All right. So we will move on to dimensions and dimensional analysis. So dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent the given physical quantity. Must be raised to represent the given physical quantity. Must be raised. It's a must. Must be raised to represent the given physical quantity. Under dimension analysis, we look at mass for M, length L, and T, time. So for example now, the formula for force is equal to mass times acceleration. Mass times acceleration. Acceleration A is force is equal to mass times acceleration. Acceleration A is equal to V over T, which has a unit of meter per second square. Meter per second square. So we can rewrite the unit as M over S square. Now, if I convert this to dimensional formula, remember in dimensional formula, we use M for kilogram. M, whenever you have kg, kilogram, you represent it with capital M. Whenever you have length, that is meter, you represent it with capital L. And whenever you have time, that is unit of second, you represent it with capital T. So now, if you look at acceleration, we have M. So if you look at the formula for mass, unit of mass, acceleration, unit of acceleration, meter over second square, meter, M. So we represent it with L. Then second, time, we represent it with T square. So we have acceleration represented in dimensional formula as L over T square, which is the unit, meter per second square, L over T square. Now, If I convert this unit and rearrange it to have all represented at the numerator, all represented at the numerator, A will be L. Remember, this is over T squared. So if I move T squared up, it will be T minus raised to 2. T raised to minus 2. That is what I will have. So my acceleration is represented in dimensional formula as Lt minus 2. That is meter per second square. Meter per second square. Now, remember that force, the unit of force is mass times acceleration. And we said mass, the unit of mass is kilogram. So we represent it with capital letter M. So if I want to write the formula for force, which is mass times acceleration, that will be written as M L T minus 2. M L T minus 2. So that is the dimensional formula for force, MLT minus 2. That is how to derive dimensional formula for any quantity, any physical quantity. Now, this is dimensional formula. Now, what is the dimension? From our definition, dimension is defined as the powers, underline it. The powers to which the fundamental quantities must be raised. So what are the fundamental quantities? They are the MLT. They are the fundamental quantities. So the power to which they are raised to represent the given physical quantity is known as the dimensions. So now we have MLT minus 2 as dimensional formula for force. Remember that when we have just a letter, let's say F, or a number 2, we believe that it is raised by power 1, isn't it? If you remember that all figures, all numbers are raised to power 1. So if we take that into, apply that knowledge to what we have here, it means that in this formula, force is equal to MLT minus 2. It means that M is raised to 1, L is raised to 1, and T is raised to minus 2. The powers to which the fundamental quantities must be raised. So what are the powers that the fundamental quantities are raised for force? 1, 2, and minus 2. Sorry, 1, 1, and minus 2. 1, 1, 1 for mass, 1 for length, and minus 2 for time. So these are the dimensions of force. The dimensions of force are 1 in mass, 1 in length, and minus 2 in time. I hope this is taken. Right, so let's move on. So dimensionless quantity simply means that such quantities do not have dimensions. So in dimensional analysis, dimensionless quantities is a quantity to which no physical dimension is assigned. Example is strain, specific gravity, angles. Strain is change in length. Strain is change in length over original length. Change in length over original length. The upper part, change in length as a unit of mass. The lower part, length as a unit of mass. The unit cancels, so we have 1. So any physical quantity whose dimension that is said to be dimensionless is said to have SI unit of 1. That is what we can say. Because the unit must have cancelled out, so it has the unit of 1. So that is dimensionless quantity. Dimensionless quantity has unit of 1. Now, what are some examples of dimensionless quantity? We have talked about that. So let's move on. Now, dimensional analysis. Dimensional analysis is a practice of checking relations between physical quantities by identifying the dimensions of the physical quantities. These dimensions are independent of the numerical multiples and constants, and all the quantities in the world can be expressed as a function of fundamental quantities. So only quantities with like dimensions can be added.
Sorry, I'm not here as well.
And can be added, subtracted, or compared. And that will lead us to what is called principle of homogeneity of dimensions. So in physics, you can only add physical quantities with similar dimensions. You cannot add mass and time. That is like this, m plus x. When you know that this is unit of, this is mass, this is meter, and this is second. You can multiply, you can divide, but you cannot add them because they are not of the same dimension. It goes against the principle of homogeneity. And the principle states that the dimensions of all the terms on both sides of an equation must be the same. Must be the same. So I can only add second plus second, meter plus meter, kilogram plus kilogram. That is, I can add 2 masses, I can add 2 lengths, I can add 2 time, but I can't add length and time. I can't add mass and time. I can't add mass and length. But I can multiply, I can divide. When I multiply and divide, I'll get derived quantity. So note this, very important. It will help you in problem solving and also to identify if an equation is correct or wrong. And that is what dimensional analysis is all about. Dimensional analysis is the use of sets of units to establish the form of an equation, or more often to check that the answer to a calculation has a guard against simple error. That is what dimensional analysis is. It's also a method of analysis in which physical quantities are expressed in terms of their fundamental dimensions, that is often used when there is not enough information to set up precise equation. So note this is very, very important. Now, dimensional formula, I've explained this to you before. Immediately we started this part of the class. Dimensional formula. So when we have a physical quantity represented in MLS form, MLT form, this is together, this is called dimensional formula. Now, applications of dimensional analysis. Dimensional analysis are applied to check the correctness of physical equation, to find dimensions of new physical quantities, to derive a relationship between physical quantities, and to convert units of physical quantities from one system to another. We have talked about conversion of units from one system to another, from lower to higher or from higher to lower metric. So we can convert from centimeter to meter, from meter to kilometer, and so on. But dimensional analysis method of conversion is different from just dividing by 100 or multiplying by 10 or dividing by 1,000. So we'll look at how it is done by applying dimensional analysis. So now, our time is up because I intend to have just 1 hour class. So we'll stop here. Can we have 1 hour class again tomorrow?
Yes, sir. Yes, sir. Yes, sir.
Okay, 4 to 5, so that we'll round up this topic for this week. Ordinarily, we are supposed to have 2 days, Monday and Tuesday, but I thought you were coming physical. So I prepared for physical class, not knowing that it's online. So, let's meet tomorrow, 4 to 5 again, online, to finish up with this topic. So don't forget, tell your classmates, I've sent the YouTube link to this class.
Okay, sir.
All of you go back there, you can watch over again, listen to the
Yes,
teaching,
sir.
but the most important thing, you must
Yes, sir.
subscribe. So subsequent classes, once I start the class online, you get the prompt that class have started.
Yes, sir. Thank you, sir.
Okay,
Yes, sir.
bye-bye.
Yes, sir.